guys. Apparently where we left off, modular programming. Modular programming is breaking up a program into smaller manageable functions or modules. Quite often that involves actually breaking them up into separate files as well. And in a particular style of programming, you create what are known as classes. And each class goes into its own file. And then you'll have a header file that is associated with that class. The header file defines the interface for the class, and then the CPP file should contain the body of the class. Some languages do not distinguish between the interface and the body. Java, being one of them. C++ does. So defining and calling functions. The function definition of the statements that make up a function. The function call is a statement that causes that function to execute. We've already been doing that. So when you define a function, you give it a return type, you give it a name, you give it a parameter list, if any, and you give it a body. If you're defining a prototype, you do all that, except instead of a body, you just put a semicolon. Our sample function definition. Every function, every program we write has a main. It's got a return type, int. It's got a name, main. It's got a parameter list. If it was going to accept command line parameters, if you ran the program from the keyboard, and you could type in dir/s, that /s is a command line parameter. And dir may be written in C or whatever, it would accept that as one of its parameters. You would have to parse the parameter list. However, we haven't been doing that. All this function does, it has 2 lines of code. It has its code block is two statements long. The function return type. In other classes, functions are divvied up into 2 types. One has got a silly word, a fruitful function. I like that, it's fruitful. A fruitful function returns a value, like it returns a number or a string or an object or something like that. If it doesn't return a value, it's a void function. So since our text doesn't use the word fruitful, I'm not going to ask that on a quiz. But this is a very common question. A function that does not return a value, what is its return type? Void. For example, any function that's not going to return a value. If you're going to print something, you may not need to return a value from it. What's it supposed to return? The fact that it printed successfully, well, it's a cout statement. It's not likely to fail. So we don't have to return anything from that kind of a print function that we've defined. So to call a function, you give the name of it, you use the parentheses, you put a semicolon, and if there are any parameters, if there are any arguments required to feed the parameters inside the function, you put them in between the parentheses. When the function is called, the program executes the body of the called function. And we could get real picky about what goes on here. What happens is if you have something there, some variable you're passing in, then a new entry gets added to the call stack. And on the call stack are placed any parameters, any arguments that you're passing to that function. And then once you're inside that function, those values, those parameters that you're passing in, get created as variables. And then those values are used inside the body of that function. And then when you hit the return statement at the bottom of that function, or the closing brace, then all of that stuff is popped off the call stack, and execution continues with a line after that function call. Here's our display message function. Hello from the function. We invoke it down here, display message. Pretty simple function. We weren't even passing any parameters to it. We could pass in a name and have it say, hello, and then print out the person's name. I'm kind of going over that fast because we have done this before. Display message. That's our function. Here's the function call. That's the invocation of it. So it's running, line by line, do that, do that. That causes execution to pop up here. It does the body of the code here. When it hits the return statement or the closing brace, it comes back down here and then continues on its merry way on the next line of code. And you can see that if you debug these things properly. We've been choosing run without debugging. but you can also run with debugging. And if you set a breakpoint, then it'll stop the program at that specific line, and you can step through your code to see if it works. So here's our the code that we did on Wednesday. I'm going to set a breakpoint here down in main after we get our choice. So choice is equal to menu there. I'm going to put a breakpoint right there, and then I'm going to run it in debug mode, start debugging. So it's going to run, it's going to ask me to type in a menu option. There we go. I want to do a pounds to kilograms, so I'm going to choose A. And now since I'm in debug mode, it's stopped at that breakpoint. We get the little arrow indicating what line is currently executing. We're executing the line of code right after that function, menu choice, because that's where I chose to put my breakpoint. So now it's going to run the if statement. So there's step into, there's step over, there's lots of different little debug options here. I'm not seeing, yeah. Step over causes it to execute that statement. Step into, if this is a function call, it would actually step inside it. But this is not a function call, so I'm not even sure why step into is allowed here. Step over. Well, our menu choice was A. How do we know that? I hover my cursor over that variable name, and it displays the value of that variable. Or I could come down here and look at the list of what it's calling autos. Autos are the automatic variables, otherwise known as local variables. So choice, in this particular case, I can't zoom in here unfortunately, is set equal to A because that's what I typed. So our our if statement was true, so now we're here. The arrow's pointing at this statement. That's going to be the next one to execute. I'm going to use this arrow, step into, and you can also find these options under here. And you can use function keys for them for ease of use. Step into is 11. So here we go. I'm going to step into this function.
Are these common options with most IDEs?
Yeah.
Thank you.
Any good IDE will allow you to debug in this fashion. Idle, which you use with Python, does not, I believe, support debugging in this fashion. I could be wrong, but there are other Python interpreters that do.
Yeah, I don't even have idle, or I just use text-based in
Yeah.
the terminal right now. So.
Yeah. Okay, so here we go. Step into, now we're inside the pounds to kilogram. If we come over here and look at the call stack, we see that we are now in a new function. We were here. We were in main. Now we're here. If we went into another function, that would be added on top of that. If we went into another function, that would be on top of that. And then when we return out of it, that entry disappears from the call stack. When we return out of pounds to kilograms, that entry will disappear from the call stack, and the little arrow will point back to main, which we'll see as soon as the main function runs. So F10. Stack. We're going to execute it line by line with the step over. There we go. It declared the variables. We see these variables show up in the list of variables down here. They are uninitialized, so they have garbage values. Negative 9.2 times, to the 10 to the power of 61. If we had said P is equal to 0 and KG is equal to 0, they would have, cleaner looking data down there. So I'm going to step over the next statement. Well, this is the statement that's going to run right now. It's the cout statement. So as soon as we do that, we will see that message appear on our output window. I'd like to have both of these up on the screen at the same time. There we go. So, step over. It ran that cout statement. It says converting from pounds. Now, this is another function. And I could either step over it, which would run it without showing me step by step what was going on, just execute the entire body of the ask function, or we could step into it. I'm curious about what it does, so I'm going to use step into. There is the ask function. Now we have something else on the call stack. We were in main, we called pounds to kilograms. pounds to kilograms calls ask, so now we're 3 levels deep into our code. And we're going to execute each one of these lines. Step over, that declares a variable in, and it initialized it to 0. Notice that we don't see the other variables right now. That's because we can't access those other variables from this context. The only variables that we can access are the ones that are declared right here, and any global variables, and we don't have any global variables in this particular application. So now here's another cout statement. It's going to print that, and then it's going to hit the CIN statement. It's waiting for us to type in something over here. I'm going to type in a number, 10. I come back over here. N is now equal to 10, and that value is going to be returned. And when I return out of here, this line in the call stack is going to disappear because we're no longer going to be in the ask method. And that's the meaning of a stack. You put things on it, and then you take things off of it. Last in, first out. If you make a stack of plates, the last plate you put on the stack is the first plate you're going to take off when you want to use it. So step over, ask disappears from the call stack. We are now back inside pounds to kilograms because we've returned out of ask. The value that we returned will be copied into the P variable as soon as we click over. There we go. Now P is equal to whatever we typed in and got returned. P is equal to 10. Now it's going to perform that calculation. Kilograms is equal to P divided by 2.2, so it performed that calculation. 4.545454. It prints it out with the cout statement when I click over again. Mass in kilograms is that. Now we have a return statement, so when I click over yet again, it's going to bail out of that function entirely. It was removed from the call stack. Now the only thing in the call stack is main, because that's where we are again. We're inside the while loop, inside of main. Now since this if statement executed, the rest of the else ifs are not going to be executed. So I click over, it should go down to the bottom of the loop. There we go. Now if choice was equal to Q, it would bail out of the loop, but it's not. Choice is still equal to A. So it's going to run back up here and start executing up at the top of the loop again. And it's going to ask for the menu. I'm going to step over rather than step inside. I'm going to choose Q this time. Is choice equal to A? No, it's not. It's Q, so it's going to skip this code. It's not going to execute that code block. Is choice equal to B? No, it's not. So it's going to skip that block as well. Is choice not equal to Q? No, it is equal to Q. So this is false, so it's not going to print invalid choice. I don't know what I just did. I think I did step into rather than step over. So now I need to step out because I'm deep inside C++'s library. So one of these is a step out. Step out gets me back out of that function. Okay, now I'm back where I was. Step over. I'm now at the bottom of the while loop. Choice is equal to Q. The while loop condition was not equal to Q. This is no longer true. It is false. So we will exit the while loop. And now we print done and we return. So that's an example of line-by-line debugging. I didn't step into every function. I didn't step into the menu function. We could have done that, but we did step into the kilogram to pounds function and the ask function, which it evokes. And you saw the call stack growing and shrinking, and you saw the list of variables here. So when you're dealing with complex code and you can't figure out what it's doing, throwing it into the debugger is the best way possible of understanding what your code is doing. Now that was a little bit far afield from this, but not really. This is just showing that if you call display message, it pops up here, just like it did in the debugger. It runs that function, then when we hit the end brace, we return out of it, and then we execute the next line. So main can call any number of functions. It's a client code. It can call as many of functions as you feel like it. Functions can call other functions. We saw that. Kilograms to pounds, or was it pounds to kilograms, whichever, calls the ask function to get a number. The compiler must know the following about a function before it's called. It has to know the name. It has to know the return type. It has to know the number of parameters and has to know the data type of each parameter, if there are any. That is why you have prototypes, because if you can't define your function above main, like if it's in another file, you have to have a prototype so that the compiler knows how to send the data to it and what to expect in return. Function prototypes, how timely. You can place the function definition before it is called, or you use a function prototype. It's just a function definition without the body. It's the header of the function and then followed with a semicolon, rather than braces.
Can you put a prototype inside of a function? I think you already answered that a few weeks ago, but I don't remember.
Let's find out, because I don't remember either.
Like if I wanted to put it inside of menu.
Okay, I'm going to make a function down here at the bottom called wow. And
You address them above main.
I'm going to put a prototype for wow inside main. Void wow, there. And then I'm going to try to call wow. Is this going to work? Let's find out. Rebuild it. Let's find out. I'm going to put a print statement in there. Guess what it's going to do since it's called wow? Give you a nickel if you guess. All right, it's going to print wow. Okay, here we go.
Satisfy people in the business prison. Sorry.
And it did print wow. So you can put your prototypes inside functions,
Thank you.
which is twisted.
You know, in my head, I have like this sociopathic code that I showed you, and it's like your worst nightmare of like looking at code where it's everything you said not to do.
I'm trying to figure out why you would do that. I guess you could overload wow with different types of definitions. You can make a version of wow that took, for example, a string. And then you could print out, you know, wow followed by their name. And you could put the prototype for that version of wow inside a different function, like kilograms to pounds. Or no, let's put it in the menu one so it gets that called right away. So void wow that accepts a string. By the way, when you're writing function definitions, you don't have to give variable names. You can just say, hey, you're going to accept a string. But the parameter names actually give you useful data. You know, like if it said string name, I know, oh, I'm passing in a name there. That makes sense to me.
Have I declared that variable already? Or sorry, initialized it if I do that?
No.
I have not.
No, that doesn't actually declare it. It's just the prototype for it. Okay, here we go. Now let's pass in Susie as our wow. And let's see if all this hangs together and actually works. It's going to work. I didn't want to debug though. Stop. Run without debugging. I need to remove my breakpoints so that, you know, if I accidentally run it in debugger, it doesn't keep stopping there. Okay, that's cool. I don't know how you thought of that. You absolutely can define your prototypes inside functions rather than having define them at the global scope.
If you have a great hat, you gotta look for stuff nobody else thinks about. That's specifically why I think about it.
All right, so when do you use prototypes? When the function that you're trying to call is defined below the code in which you're trying to call it. So program notes. Place your prototypes near the top of the program, or even better, put them in a header file. The program must include either prototype or the full function definition before any call to the function, otherwise you get a compiler error. When using prototypes, you can place the function definitions in any order in the source file. Yeah, the order no longer matters as long as you have them prototyped. So in my code here, you know, I did have a series of prototypes, including even main, which is pretty silly. So I could cut that out and paste them inside a header file. So I'm going to create a header file. I'm going to go to my project. Over here in header files, there's one called standard AFX. That got created by default when we created the project, but then we removed any references to it so we could delete it. So I'm going to add a new header file. It ends in the extension .h. Some weirdo compilers in the past made C++ header files end in .hpp, but that went by the wayside. There are my header, there are my prototypes. Inside my CPP file, I'm going to do include, and I'm going to include that header file, header.h.
Those just need to be inside the same file, right?
They need to be in the same directory or in a search directory. And there are two different symbols that you use with include. One of them means search the search path for that header file before looking in your local directory, and the other one means search your local directory first. Okay, now this isn't working at all. What have I done wrong? Well, we'll find out when we go down here. Okay, if you put quotes around it, it searches the local directory first. Let's go back to my other project. So I should have put quotes around my header file that I was trying to reference here. Now it can find it. I don't need my protos defined in here anymore because they're defined in that header file, which means that multiple programs could make references to them. Let's make sure that it works. Start without debugging. There are build errors. Identifier string is missing, etc., blah, blah, blah. So there are problems in the way that I define my header file. I'm not going to fix them right now. That's the idea behind the header file, but we don't need to know the specifics at this moment.
So the header file, like if I'm walking a executable or library with a dependency walker, is it reading what used to be just written into those header files?
Yeah, it should be.
Will it still be picking up these prototypes that we're putting in the .c++ files, the actual source code?
Yeah.
Sorry, that was kind of a dumb question.
Yeah, it should do that. All right, like I said, I'm not going to figure out. You know, part of me is screaming to figure out why it's not working, but I don't want to do that now. Okay. So the exit function. Wait, that's not right. This is totally out of order. You can kill your program if you want to. Instead of a return statement, you can use exit, and that causes the program to immediately bail out right then and there. So your functions can return a value. We saw that in our ask and our menu function. The user types in an A, we return that A. That's pretty trivial, you know. Let them type in something and then that's what we return. Mostly I did that just so that we'd have, you know, a more interesting flowchart to implement. But usually, you know, you perform some kind of calculation or something like that and you get something useful, you know, some useful bit of data based on a calculation, and then you return that. So here, he has written a function called sum. It's got a prototype right there. So the main code knows how to format the data. It knows that it needs to pass in 2 ints. Here's an example of not putting the parameter names inside the function prototype. They didn't say, you know, int x and int y or whatever. They just decided that telling you the data types is enough information for the compiler to work, and so we don't need to know anymore. And then it tells us what was returned, or what will be returned. And so using that information, we can encode a call to the sum function, passing in 2 integers, value 1 and value 2, which they're setting equal to 20 and 40. that will invoke the sum function, which has to be coded somewhere. It's just not coded above main, which is where we've been putting it. So if we scroll to the next page, there should be a sum function. Here's the sum function. It looks like the function prototype, except it actually has variable names for the parameters, and then it returns parameter 1 added to parameter 2. And so that is a fruitful function. It returns a value. Its return type is declared as type int. Returning a Boolean value. Well, that's no different than returning any other value, so I'm not sure why it needs its own slide. If you declare your function as being of type bool, it has to return a true or a false. Here's our example of returning a true or false. Enter an integer, and I will tell you if it is odd or even. So it puts on its wizard's cap, you type in a number, indicate whether the number is even or odd. They have a function here called isEven. The function prototype for isEven is shown up here. It's a Boolean function which accepts an integer and returns a Boolean value. So it'll return either true or false. Presumably it will return a true if the number is even, if it's cleanly divisible by 2, and it should return a false if it's an odd number. So when that function is invoked, it will return a value, and that value is being fed into an if statement, the conditional clause of the if statement. That is evaluated, and if it's true, then it runs the code block under if, else it runs the code block under else. So if we go to the next page, we'll see the implementation. This is the prototype, but it's not the implementation of that function. The next page has the isEven function. And we've talked about this before. How do you know if a number is even? You modulus it by 2. If you modulus it by 2 and it's got a remainder of 0, you know it was evenly divisible. So that's what isEven does. It creates a variable called status. If number %2 is equal to 0, it sets status equal to true, else it sets status equal to false, and then it returns it. So this is another fruitful function that's taking a parameter, and then based on the value of that parameter, it's returning a value. In this case, a Boolean variable, a Boolean value. This code can be shortened to a single line of text, by the way, but our goal is not to write maximally terse code. Local versus global variables. All the variables we've been using so far are local because they're defined inside a function, which means that they're hidden from statements and other functions unless you pass them in as a parameter, in which case you get the copy of that value. Because the variables are defined in a function are hidden, other functions they may have separate distinct variables with the same name. So over here, I'm going to fix this so that it doesn't use any of that. I could declare a function, void function1, and it declares a variable named x. And it sets the value of x to 10, and then it prints it out for whatever reason. Now I'm going to write another function called func2. We're bringing the func today. Alrighty, here we go. Int x is equal to 20. Now this is a completely different variable. It has the same name, but that doesn't matter. This x is local to that function. This x is local to that function. It's like having two dogs of the same name. You have a dog named Seamus, your neighbor has a dog named Seamus. They're not the same dog. This is not the same variable. That variable is local to that function. That variable is local to that function. You can do whatever you want to with this variable, secure that it's not going to change the value of that one. They're completely independent addresses in memory. Now that I think of it, that was a Pink Floyd reference. Seamus the Hound Dog from the album Metal. Okay. Alrighty. Here's our example of local variables. Num is local to the function main. And then they have a function called another function, also using a variable called num. Completely different. Just because they set this num equal to 20, that one stays 1 there. So if you were drawing your functions inside of blocks, you would show, you could list all the local variables for that function. And you could then list all the local variables for the other function. The lifetime of a variable. The function's local variables exist only while the function is executing. You know, x in my func1 exists only while the code is inside that function. That's known as the lifetime of the variable. It's also known as the scope of the function. When you leave the function, then that variable is no longer in scope. Its lifetime is exceeded, it's removed from memory. When the function begins, all the local variables and its parameter variables are created in memory in a stack memory structure. And when the function ends, the local variables and the parameter variables are destroyed. This means that any value stored in a local variable is lost unless you return it out of that function and store it in another variable. So global variables. A global variable is a variable defined outside all of the functions in a program. The scope of the global variable is the portion of the program from that definition to the end. It means that a global variable can be accessed by all the functions. So I can go back in here and in func1 and func2, I can make a new variable. I'm going to call it Fred. It's an integer. Fred, for some reason, is equal to 99. I can access that variable inside any function underneath it. And now this is the same variable. If I change the value of Fred inside func1, I need to pick a different name. That's all right. If I set Fred equal to 10,000 inside of it, I'm renaming this function1, then that value change sticks. So that when we go into function 2 and we print Fred out, it will print out 10,000 rather than 99, assuming that we call them in that order. If we call function 1 before we call function 2. So if you declare a variable outside of the functions, it's a global variable. If you put a variable declaration inside the function, it's a local variable. Global functions, that variable is accessible to all the functions. However, you can declare a new variable with that same name, and that kind of hides that variable. Like here I may make a string called Fred inside function 2. And I'm going to assign the value Flintstone to that variable. Now when I print out Fred here, it would print out Flintstone. This is a completely separate variable. It's even of a separate data type. Doing this assignment here does not change the value of this variable. They are again two separate things, because one is a local variable and the other one is a global variable. Now that we've done that, we don't have any way of accessing that variable Fred inside function 2, the global variable, because we already have a local function with this, a local variable with the same name. You should avoid using global variables because they make programs difficult to debug. Then once you get the idea of global variables, they become very seductive. So just start. The way you get around using global variables and littering your program with them is by object-oriented programming. So since we're not there yet, just remember, global variables are generally frowned upon. If you make a global variable, it should be a constant, meaning that its value doesn't change. And the reason for that is you could have 10,000 lines of code that are referencing those global variables. And if you change that global variable in one function, it's going to change it for all those functions. And maybe you knew not to do that, but you give your code to some other programmer and he goes, oh, well, Fred's not supposed to equal to Flintstone. It's supposed to equal, some other person with the name Fred. Durst, Limp Bizkit. And then, then your program breaks because it no longer equals Flintstone because he assigned it a different value inside that function. So here's how you define constants. These are global constants. You use the const keyword, followed by the data type, followed by the variable name, and by convention, in almost every programming language, in almost every programming shop, constants are defined in uppercase letters to differentiate them from your local variables, which are lowercase letters. And since it's a constant, you have to give it a value. Why would you define a constant that wasn't initialized with any value? I don't know. So you have to give it a value. And once you have done that, once pay rate is equal to 22.55, none of your code down here can change that. So here I changed the value of Fred to 10,000, but if Fred was a constant, this is now an error. It's underlining it. We cannot reassign the value of Fred to a different value. This means that value is immutable. Can't change it. However, what it really means is just don't let the compiler compile the code that would change it. If you have some kind of weird memory overwrites going on because you have buffer overruns in your program or whatever, that magic keyword constant doesn't just somehow miraculously make that variable never change. But it does tell the compiler, don't allow the programmer to write any code that would change the value of it. Yeah?
If I don't include a value in the initialization of a constant, will it let me assign it a value one time? Or is that just, yeah.
Let's find out. I'm going to do constant int Fred here, and then maybe inside of
It took away your error.
it took away my error. That's scaring me.
And then my second question was going to be about if it initializes it with the data that was already in that physical space.
Check that out.
Yeah, using it as a pseudo-random number a cheap pseudo-random number generator.
So if you do that, you can only define it in one place. And the value you assign to it, I bet, has to be a constant. I bet I cannot do this. I bet I cannot assign x to the value of Fred because it doesn't know at compile time what the value of x is. Pardon me?
The first instance of Fred, is that the first instance? Oh,
Yeah.
yeah, it is. I'm sorry.
Right, yes it is.
I'm being-
So if x was a constant itself, that would take that error away, right? No. You know what, now it's going to keep underlining that and showing it as an error when before it did not. I'm coming to the conclusion that you have to,
Best practices don't do what I said.
yeah. Not only best practices, but apparently the language is now enforcing that, even though when I typed it a minute ago, it did not. Maybe I didn't save it. And so maybe it didn't run the compiler against it. Yeah, you have to assign it. You can't just leave it blank and then assign it later. Which would be kind of neat, like, you know, random number, like you said, and then use that random number throughout the program. If you're going to do that, just don't make it a constant.
So that's what it'll do here, right? If I was to use Fred somewhere else and not initialize it with a value, it would give it basically whatever data was already in that physical space.
Right, but the compiler tends to initialize it, at least if you compiled it for debug mode, with a very specific value. So when you ran it, it would give you the same, what you thought was going to be a random value over and over and over.
Why do I keep on rolling a 7?
Yeah.
There are only 6 sides on the dice.
Do you even crit? All right, here we go.
Meme of the week.
So they define some global constants here, and then their functions use those. The base rate, the pay rate, and the multiplier for overtime. And you just use these constant variables like you do any other kind of variable. You can use them in calculations. You know, base pay is equal to base hours times pay rate. Once you've defined it as constant, it's just a variable. There's nothing unusual about it except for the fact that you can't change. The compiler will not compile code that attempts to change that variable. So local variables are not automatically initialized. And this would be why we can't change the value of Fred. Global variables are initialized, and they're initialized to 0 when the variable is defined. So over here, if I left off the definition of Fred, but I tried to print it out, it's going to print 0. So if you do not give it a value, defaults to 0. And not only is it default to 0, it's stuck at 0 for, you know, the execution of your program. Static local variables. Static variables in C++ are very different than they are in other languages. So if you've taken Java and you think you know what a static variable is, then you don't really. And if you're a C++ programmer and you go into Java and you think you know what a static variable is, again, you don't. They're related concepts, but they're different. What a static variable is it's a variable that's not destroyed when you leave that function. It maintains its value so that you could with the next time you go into that function, it'll still have the last data that you set to it. So static local variables can retain their contents between function calls. The memory allocated for them sticks throughout the lifetime of the program. Static local variables are defined and initialized only the first time the function is executed. 0 is the default value. Let's see if he's got an example of that. No, not there. Okay, here he's got a variable that he's declared as static, meaning that it's in stasis? I don't know. That it is not destroyed when you leave the function. So whatever you copy into that value will stick, and the next time you call that function, it'll still have that value. In this case, they're increasing the value of this variable by 1 every time that function is called. So a static variable defaults to 0, or it is initialized only the first time it is run. So if we set it equal to 100, it would not be reset to 100 the next time we hit that statement. So it defaults to 0, and then we print out a message, and then we increase it with stat num plus plus. The next time we call show static, that number is now 1 because it was set to that before we left the function. And it's a static variable, meaning that the memory for that is not declared on the stack. It's declared independently in a different part of the program so that it stays. It's not dependent upon whether you're in that function or not. You still have to be in that function in order to access it. Kind of the difference of if you had a holodeck that every time you walked into it, it reset back to the default characters and they didn't know you. But if you made them static, then when you walked into that holodeck, the characters would recognize and remember everything that happened before. I don't even know if that helped at all. Okay.
The next generation, yay. Sorry, I'm really tired.
Default arguments. If you want, you can give a function a default argument, or you can declare the functions so that it has a default argument. And what does that mean? That means that you won't have to pass a value to it when you call it if you don't want to. So here's what that looks like. I'm going to write a function 3 now, but I'm going to put it above these two functions just because. And it's going to take a variable called name so that we can say hello. So cout hello followed by their name. And then return. But we're going to give the programmers who use this function the option of not specifying an argument. So we're going to give it a default value. If they don't specify a name, we get to fill in a name for them. We're going to use Lady Gaga as our name. There we go. So when we call function 3 from our code, we could either specify the name, hey, I want you to print out the name Fred. And when we do that, then this variable has that value. When we invoke function 3 and we pass in that as an argument, when we pass in Fred as an argument, this variable gets that value. And when we print it out hello, it'll say hello Fred. But then if we call it a separate time and we don't give it a value, then that function, that parameter gets filled in with this default value. And so instead it'll say hello Lady Gaga. So that's a default function. Or a default parameter. using reference variables as parameters. Now we're getting into some abstract stuff here. A reference variable, normally if I pass a variable in, I'm passing in a copy of the variable. It's like I wrote a name down and then I gave it to you. You know, and I wrote it down on a piece of paper. You have the copy of it. I still have the original. You could turn around and you could tear that paper up and write something else on it. It doesn't matter. I still have the original data. That's known as pass by copy or pass by value. It's when the parameter gets a copy of the data that is in the argument. And that's what happens by default. So when I call, I shouldn't use the word default because I'm using a default function here. But when I call function 3 and I give it an argument, that value is copied into this variable. And then if I change that variable, you know, I decide that name is no longer going to be Fred, it's going to be Barney, then that doesn't matter, you know. That data is lost when we exit this. Doesn't do anything because all this variable is, all this parameter is a copy of whatever was passed into it. But there's a way that you can define your parameters so that you can get to the original variable, and if you change the value of it, it actually changes it for the calling code. That's a little bit abstract. And why do you do that? Well, because you can only return one value. You know, you have a return statement, and some crazy languages like Python let you return more than one value. However, most languages only have a return statement, and you can only pass in, you can only return one value. Or you could do something like return an array of values. But what if you want a function that'll return 3 or 4 different values? You want to write a function that'll ask them for their age and for their height and then, you know, for their employee ID, whatever. And you want the ability to return those 3 values. Well, you can't just use a return statement for that. So a reference variable is an alias for another variable, and you declare it with an ampersand. And here's what it looks like. I'm going to write a function that changes the value of the name. So let's write a function called function4, void function4. It's going to accept a name, but the name in this case is going to be a reference to the original variable. And all it does is change the value of that to, wow, the name has changed now. Now I'm going to grab that code and go find main so that we can actually plug it in. Here we go. So as soon as we enter main, I'm going to set a variable called, and it doesn't even have to match its name. The variable names don't even have to match. So I'm going to call this one S. And I'm going to set the value of it to Sally. Then I'm going to print that out. Cout S, end of line, that will print out Sally. Now I'm going to call function4 and pass in Sally as my variable. And then I'm going to print it out again. And I'm going to exit out of the program completely. But that exit statement that we briefly mentioned kills the program right on the spot. Okay, here we go. It doesn't do a dang thing because I got some compile errors. Constant object must be initialized if not extern. Okay, fine. I can do that. You weren't complaining about it earlier, but you want it now. Okay. And now wow is not found. Well, I deleted the prototype for wow. I'm going to delete all those references to wow. Okay. So the name equaled Sally, and then it called function4, and then it tried to print the name out again, and it said, wow, the name has changed now. That's kind of dumb. I should have actually made it, you know, something that looked like a legit name, you know, Beth or something like that. I'll do that. So that data actually changed. But if I write this same function, but I don't pass it in as a reference, if I delete that ampersand symbol, then whatever I change it in here to, like Mary, it's not going to change the variable itself. It's just affecting the copy of it. It's just affecting the parameter that was passed in. Okay, so the name is Sally. I call function 4. After function 4 is done, since it was passed in as a reference, passing it in as a reference means that that parameter now contains the address of the original variable. So when it changes it here to Beth, that's changing the original memory space. And so now this variable S down here actually has those new contents of Beth. But when we call function 5 and we pass that in, this is not declared as a reference. So that means that name just contains a copy of what was given to it. And when we change that to Mary, it doesn't matter. It's just a copy. You know, I handed Kevin a Xerox copy of the name that I wanted him to play with, and he wrote the name Mary on it. It doesn't matter. He doesn't have the original document. He can't change that. He doesn't have the original memory address. It's pointing to somewhere else. So when we try to change it here to Mary and then we print it out again, it will not be changed to Mary. It will still have the last value that was set to it, which was done in function 4, which was passed by reference. Now notice that you can't tell that it was passed by reference here. There's nothing in this syntax right here that lets you know, oh, by the way, we're passing that by reference, because it's defined in the function header. It's not defined right there. There's no special symbol. That's unlike the C# language, where if you pass in something by reference, you have to put something special right here, and you put it right there. And that lets you know even when you're invoking it that you're passing in a reference. Yeah?
Sorry I'm raising my hand so much.
I like it.
Oh, cool. John, that's not a comment, was the first thing. I was also going to ask if you have, wow, what's wrong with me today? The and sign in the, we were talking about it right now. Does that work in Python too? Is there a way to do that in Python? No?
No, but in languages like Python, if you pass in an object rather than a primitive data type, then you can change the member values of that object.
Oh, yeah.
So that makes it look like it's passing by reference. It's still, that object, that parameter has a copy of the data, but what data is it getting? It's getting a memory address. And since it has a copy of it, then you can change the values of it and it changes the original object. But if you try to pass in an int or a string or another primitive data type, it's not, you can't change the data. So both Java and Python are passed by copy only. They do not allow passing by reference. C++ and C# do.
So that's the only seem like lower level coding.
So function 4 passes by reference. So any changes done to the argument also will affect the S variable here. Function 5 is not passed by reference. It's passed by copy or passed by value. I don't remember which term this text prefers. Let's go look. Passed by copy. Is that what it likes? Nope. Passed by value. Yeah, okay. So this book uses the term passed by value. Good enough. Normally when you invoke a function, you're just sending a copy of it. And this text calls that pass by value rather than pass by copy, but they mean the same thing. You're just getting a copy of the value. However, if you declare it as a reference with the ampersand, then when you call it, you're passing in the original memory address, and so they both point to the same thing. A reference, this text calls it an alias, but just think of it like if you have one store and you have two signs for that store. You know, you have a sign on the north side of the store and you have a sign on the south side of the store. Both signs reference the same store. Just because you have two signs for it doesn't mean you have two different stores. They are both references to the same store. So if you burn that store, you know, this one sign is pointing towards a burned store, well, so is the other one. Because if you only had one object, one memory address, you had two variables that referenced it. My example got violent pretty fast there, I don't know. Let's see here. Okay, so if you pass by reference, any changes done to the argument affect the original parameter. I read that wrong. So any changes done to the parameter will affect the S variable that was passed in as an argument. The parameter is a reference, an alias, a something. It is the same thing as the argument that was passed in. That kind of implies something. What if you tried to pass in a constant here? Like what if I tried to pass in the word, we've already done Lady Gaga, so we're going to use Madonna. Alrighty, here we go. It's not even going to let me do that. Why? Because function 4 is defined as taking a reference. Well, you can't use a constant as a reference because that's implying that you're going to allow that value to change. How would you change this string, you know? I mean, it's hard-coded into the program. It's never going to change. So you can't pass in a string literal like that as a reference. You can't do the same thing for numbers either. If you declared a reference to an integer, you couldn't pass in 1. However, you could copy the value 1 into a variable and then pass that variable in. That would work just fine. It would work as intended. So pass by value. That means when the argument is passed to the function, its value is copied. Changes to the parameter do not affect the value of the argument. Maybe that's a better way of wording it than what I did, so I'm going to paste that on here. Whereas pass by reference does what we were just talking about. You get the original data. So why do you use that? Just like I said, to return more than one value out of a function. Like what if you want the function to build somebody's name, given a first and a last name, you know, or an access from a database, but you also wanted to return an error code if it could not open the database. Well, you make the return statement return the area code, and then you make the name a reference. So we're going to write a function called makeName. Or heck, let's call it int. We might return an area code, you never know. And it accepts as a reference a first name and a last name. And when you call that function, it assigns a value to first name. It opens up the disk, it reads it, gets the value Ringo out of it. And then the last name is also assigned some value, star. There we go. So when we call makeName, we pass in two variables. Since these are reference variables, the changes stick. And we can actually use those in the client code down here. So I'm going to declare two strings. I'm just going to call them fn1, or fn for first name, and then string ln for last name. I usually don't do that because it looks like a 1. And now I'm going to call makeName, and I'm going to pass those two things in. makeName, passing in those two variables as arguments. They are reference variables as defined here in the prototype in the header definition, which means that when these values change here, they also change these original variables fn and ln. So when we print them out, it will now say Ringo Starr. And let's prove that to ourselves. correct that error. The one where I passed in a string constant. All right, and then let's return a 0. So what I'm pretending is that I referenced the database, or I asked the user for the last name and the first name. I could type in, I could actually use cout or whatever. And then we're returning some value. Well, the return code can be inspected to see, whether the function works successfully or not. And we might say that a 0 means it worked correctly, and that a non-zero value is a return code. That way you can have different, numbers based on what kind of error occurred. 1 for could not open file, 2 for, index corrupted, 3 for I'm lazy and I don't feel like working, whatever. So, F name and L name do get filled in with values, and both of these values that are filled in are in effect returned to the code. They're not actually returned. They're not returned with a return statement, but those variables were passed in as references, so we have that data now when we're done with make name. So when I run you, right here, you should print Ringo Starr. Except it ran too quickly. Really? Okay, fine. There we go. And indeed, it did indeed print Ringo Starr. If I had not declared these as reference parameters, if I had not put the ampersands on there, then when I change these values, they would not change down here. So fn, maybe I initialized it to, default, some word like that, and then ln, I initialized it to default. Since I removed the ampersands from the parameters in the function prototype, the function header, the changes to it no longer stick. So when I print it out, it prints out default. That's not what I want, so I'm going to go back in now to my make name, and I'm going to add those ampersands again. I'm talking a lot about that. I'm hoping it's sticking. It may not be. I may have to. We'll do that in an in-class assignment to try to make it stick. So I guess we could say pass by value is like if I hold up a sheet with the name to the window and you take a picture of it on your cell phone. I still have the original name. I still have the original paper. You can't do anything to it. You can delete the picture, or you could draw a smiley face and a mustache on it, on your own phone, but it doesn't change my picture of it. However, if you do pass by reference, it's like I actually give you the document, and you can change it if you want. And then when you return out of that function, then I have the modified version of the document with any changes you made on it. So, notes about using reference variables. Each reference parameter has to be defined with an ampersand. You have to use the ampersand in both the prototype and the header. So if I was going to declare a prototype for that function, it would look very similar. Let's go back to make name and make that a function prototype. Now I could come up here and stick that in my prototypes. There we go. Has to match. It doesn't matter whether you put a space there or not.
If I prototype it like that and then I don't include those terms in the actual function, will it still pass by
No. No, if I go down to make name now and I remove those,
It still won't do it.
it shouldn't compile. If it is compiling, I'm surprised. Okay, build error.
Thank you.
Alrighty, I think that's about it. We have 1 minute. What are we going to lecture about in that 1 minute? I'm going to have to talk really fast. Overloading functions. Yeah, that's a long topic, kind of like passing references was a long topic, so we're done.
What's your opinion on Charlie the Unicorn? non-believer. John.